In the previous videos on trig graphs, we looked at the graphs of the sine function and the cosine function between 0 and 360 degrees, one cycle. There were 5 key points marked in the graph: the maximum turning point and the minimum turning point, and where the graph met the x-axis, that's where the y-coordinates were 0. We wanted to know the coordinates of the images of these points under any graph transformation. So we will label the graph with these points. To remind you of the transformations involved, here's y equals sine x, peaks at 90 degrees 1, and its minimum is 270 degrees negative 1. 4 transformations were looked at in previous videos. The first was a y stretch, as if the graph's made of elastic, you stretch it in the y direction. It stays at 0, 0, 180, 0 and 360, 0 because the y coordinate is 0, and the effect of this change is to multiply the y coordinates by 3. Sine x is the y coordinate, it gets multiplied by 3, so these stay where they are, whereas the position at 90 degrees, which was a y coordinate 1, is now y coordinate 3. At 270 degrees, y coordinate negative 1 became y coordinate negative 3. So that's a y stretch. Second change that was looked at was affecting the input to the function, the x coordinates in the graph. So here y equals sine 2x. Because when you substitute for x it gets doubled, you can put in half of what you used to need to get the 90 degrees. So that means you put in 45. Or to get the 270 degrees, which means you just put in 135. It basically halves the angles. Every angle in the graph has been halved. That's why the period is 180 degrees. Third change we looked at was simply sliding the graph up or down in the y direction, or a y shift. So sine x is the y coordinates, this adds 2 onto the y coordinates. So 90 degrees peaked at 1, add on 2, it becomes y coordinate 3, so it peaks at 93. 270 degrees here, it went down to negative 1, so the y coordinate was negative 1. If you add 2, you get positive 1. The minimum turning point here is 270 degrees 1. And the third change that was looked at was this here. I've taken x and I've added 30. The effect on the y coordinates is that because in the brackets 30 is being added, you can put in 30 less than you used to. So when you wanted 90 degrees, you don't put 90 in, you put 60 in, because it's going to be 60 plus 30 and that will make the 90. So this actually causes the graph to move to the left because the x coordinates lose 30. In the same way, in the same way, if in the brackets it says x minus 30, you must put in 30 more for x to compensate for this 30 being taken away. So when you want 90 degrees, you've got to put in 120, because 120 minus 30 makes the 90. So your angles go up 30 degrees, and that makes the graph move to the right. So that's, it says minus 30, you actually add in 30 to the x coordinates. So that was the changes covered in these previous videos. The basic changes are, you're multiplying by a number. In front of the trig function, you multiply the y coordinates. There it is, ky. If you're multiplying the x, you actually divide the x coordinates by that number. If you're adding into the x coordinates, here x plus k, you actually take k off the x coordinates. Here, sine x is a y coordinate, you're giving it an extra k, that's all you do, you give y an extra k. Same process for the cosine function. To put numbers in their place there to make it easier, when we carry out graph transformations to look for maximum values, we'd want to know 90 degrees 1 for the maximum, 270 degrees negative 1, how do they change? Well, here's 91, the peak of the sine curve. If it's 10 sine x, 10 times the y coordinates. 91 became 90, 10. If If it says 10x here in the brackets, you divide the x coordinates by 10, so 91 became 91. It says x plus 10 in the brackets, that means take 10 off the x. 91 became 81. This is the y coordinate sine x, and we added 10. So you basically add 10 onto the y coordinate. 91 became 9011. These are the images under the transformations. That's 4 different transformations. This is the points being transformed. So that's graphicacy. Here's an example of a graph with this equation and how it changed. It's got a plus 4 here. That shifts everything 4 up. This 3 has stretched the graph 3 units. This gap here to the dotted line is 3, that's the amplitude. The dotted line is the mean position, y equals 4. This 3 makes it go 3 above and 3 below the line, giving you maximum 7, minimum 1. The 2x half the angles. That's why one cycle in 180 degrees, and it's quartered off here at 45 degree intervals. So the peak 45, 7, the minimum 135, 1. But without that, you can get it without looking at the graph. So if the graph wasn't there, you can look at this equation, y equals 3 sin x, 3 sin 2x plus 4, and consider the turning point 91 and 270 negative 1, the maximum and minimum. Think of what these 3 numbers do. What does 3 do, what does 2 do, and what does 4 do? Well, 2 halves the angles. So you simply half the angle. 90 gets halved. What does the 3 do? It takes the y coordinates, sine of an angle is the y coordinate, multiplies it by 3. So, with this, you multiply the y coordinate by that 3. And this adds 4 onto the y coordinate. And then you add 4. So you take the y coordinate, you multiply by 3 and add 4. Half the x coordinate, multiply the y coordinate by 3, add 4, you get 7. The maximum value is 7, and it happens at 45 degrees. And then simply do the same with the other point. Multiply the y coordinate by 3 and add 4, and half the x coordinate. That's therefore the maximum minimum turning point. We can forget about the graph. You just need to know these 2 points, 91 and 270 negative 1, for sine, and half the x coordinates, and multiply the y coordinates by 3 and add 4. So now we don't need the graphicacy anymore. Here I'll do it for the cosine. So this is what the graph looks like. It's been shifted 2 down for this minus 2. It's been stretched by 4, which is why it goes 4 above negative 2 and 4 below negative 2. The 6x simply changed the period. That's why it's 60 degrees. Now, normally cosine, when we think of the cos x, we can think about these points 0, 1. Now usually 0, 1, but some cases we take 360 degrees 1. The minimum's at 180 degrees negative 1. So you think of what the 3 numbers do rather, on these 2 points. The 6x divides the x coordinates by 6. This 4 multiplies the y coordinates by 4. So here it is. And this takes 2 off the y coordinates. There's the changes. Divide 0 by 6. And for the y coordinate 1, it gets multiplied by 4 and take off 2. There's the result, 0, 2. And there it is in the graph. Do it for 180 just the same. Divide 180 by 6. And take the negative 1, multiply it by 4 and subtract 2. And it's 30 negative 6. There it is, 30 negative 6. So that's the maximum minimum turning points. Now the values is the y coordinates. If you're asked the value, so you've got to watch whether you're asked the value, which is 7, or whether you're asked the turning point, which is 45, 7. Basically, we can do away with the graphs. So I'm going to take the same 3 numbers here along these points and show you how you can get the maximum minimum really easily and quickly. I'll do it with the cos. So this is the same functions again, but what I've done here, I've missed out the y equals. This is now just a trig expression. We want to know what's the maximum value of this trig expression, what's the minimum. If it had y equals, it'd be a turning point. I'm actually going to put them as turning points at the end because we just met them as turning points. But all you need to know is it's sine. Think maximum 90 degrees 1, minimum 270 degrees negative 1. So as long as it's sin, it's these 2 points. Then think this. You don't need to think about graphics anymore. All you do is you say, I want this brackets to be 90 degrees. I'll make it 90 degrees. This bracket's to become 90 degrees because sine 90 is 1 and you can't get any more than that. So you want a maximum. You can't get better than sine 90 being 1. That means that's 3 times sine 90 is 3 times 1. And there's the answer, that's 7. All you do is now you say, how do I make that brackets 90? Obviously 45. There it is. And now we've got a turning point 45.7. Value is 7, the turning point is 45.7. You can do the same with the minimum, but the angle's to become 270. So you want this to be 270. 3 sine 270 plus 4. So that's what you've got. Sine 270 is negative 1. You can't get lower than negative 1 for sine x. So you can't get lower than sine 270. There's 3 times negative 1 add 4, and it gives you 1. When does the brackets become 270? Well, obviously you need 135. And that's the same answers as before, but no graphs involved. All you have to think is sine 90 and 270 and put them in. Same with the business with the cosine. So there's the cosine case. But this time, remember, maximum happens at 0 degrees, and the minimum at 180. So all you do is you make the angle 0, cos 0, can't get higher than 1. There's the answer. When does that brackets become 0? Obviously when x is 0, but there would be an equation. The minimum, I want the brackets to become 180, so I make the brackets 180. Cos 180 is negative 1, and you can't get lower than that. 4 times negative 1 subtract 2, there's the minimum value. When does the brackets become 180? Obviously you need 30 there, but there would be the equation. Same answer as before, and we've got the maximum turning point and the minimum turning point, just what I had in the last example there with doing it with graphs. We don't need that anymore. This is all you have to do. And the cases are more complicated than that because look in the brackets, there's a phase change as well. But the process is the same, so it's not difficult. So this is not any harder. I just want the brackets to be 90. So for a sine, I want the brackets to be 90. I'll make the brackets 90. 5 sine 90 plus 3 sine 90 is 1. So I can't get any better than sine 90 degrees. There's no other angle I can put in that will take me above being 1. And all I do now is I say, I want to make that 90. What's x got to be? That twice it take away 30 makes 90. Well, there's an equation. 2x must be 120, and then x is 60. So when x is 60, the maximum value comes out 8. You do the same with the minimum, but you want to make the brackets 270, so you just make them 270. Doesn't matter what's in there. It's becoming 270 because you can't get any lower than sine 270, which goes to negative 1. There it is. So the minimum value is negative 2. So what makes the brackets 270? You've got to figure what value of x will make 270 here in the brackets. So you just solve the equation. Put 30 onto the other side and divide by 2 and it's 150. And now you've got it. 68 is the maximum turning point, 150 negative 2 the minimum. So it doesn't matter how complicated that expression is in the brackets, you're going to make it for a sine 90 and 270 and then you just work it out. And then you just figure out what x has to be to make these values 90 and 270. Now that's for sine. What I'm going to do is going to change this to cosine. It's still going to be the same expression, but instead of saying sine, it'll say cosine. There it is, it just says cos, and the only difference that makes is we look at 0 degrees 1 and 180 degrees negative 1. You're doing the same as before. You make it the angle you want. I want this to be 0 degrees to get cos 0 because that's the maximum. Cos 0 is 1. There's the maximum 8, just as it was before because we only changed that from sine to cos. All it changes is where the maximum and minimum occur, not what they are. So you want to make the brackets to be 0. That makes 2x to be 30 and x to be 15. The minimum, you want the brackets to become 180 because cos 180 is negative 1. And you can't get any lower. the negative 1 for the cosine of an angle. So you make the brackets to become 180. That's 5 times cos 180. Well, that's 5 times negative 1. There it is worked out. It's exactly the same as the sine case. And the only difference is I want to make the brackets 180. So you figure out what makes the brackets 180. And now what you've got is the same answers as previously as far as the maximum 8, minimum negative 2, but where they occur, here it's 15 and 105, that's what's different. So trig expressions, you just got to decide, is it sine or cosine? In the case of the sine, you want the brackets to be 90 and 270. In the case of the cosine, you want the brackets to be 0 or 180. Now, if that had said 2x plus 30, you would use the 360 degrees one, because if you use 0, you're going to negative angles. So that's the only reason you get the 360 there. If you use 0 and it went to negatives, you would use a 360 instead. Usually these questions are in a context of some sort, such as, which I'll show in a wee second, depth of water. So some context, so the depth of water in the harbour is h, the time after midnight is t. That function here tells you the depth of the water in the harbour at a particular time of day. And it says what are the depths, that is what's h, and at what times, that's what's t, when it's high and low tide. Well, that just means that what's the maximum minimum. So all you're going to do is look at that expression and do what we just did. It's just in context. Make the brackets 90 for the maximum and make it 270 for the minimum. Now this is exactly the same business as before. 10 sine 90 plus 15. 10 ones, add 15. 25 is h, that's 25 metres. Next, when did it occur? When did 12t plus 18 become 90? Because you want to make the brackets 90. So solve this equation, taking 18 off the other side, divide by 12. T6, what did that mean in the context of the question? Well, it was the number of hours after midnight. So that's like 6 a.m. It's 25 metres deep at 6 a.m. So that's your answer in the context of the question. For the minimum, you want to make the brackets 270. 10 sine 270, add 15, sine 270 is negative 1. That comes out at 5. The depth's 5 metres, so at low tide. When does the brackets become 270? When 12t plus 18 equals 270, you take 18 off and divide by 12. 21 hours after midnight. That takes you to 9 p.m. So it's 5 metres deep at 9 p.m. Now, no matter how complicated that function looks, you're just making the brackets 90, making the brackets 270, plugging it in and figuring out what t has to be in that case. And it's because it's sin and it's these two red coordinates there that you're transforming. So no graphs involved. Here's the displacement of a piston, d centimetres at time t seconds, given by this expression. Displacement is a distance in a direction, so it's time t seconds, and d is a distance in centimetres. Find the maximum minimum displacement, so it wants the maximum minimum values. So it's a cos function, 0 degrees 1 for the maximum, 180 degrees negative 1 for the minimum. So all you do is make the brackets become 0 degrees. 5 ones add 10. When do the brackets become 0? Make what's in the brackets equal 0 and solve the equation. 2 seconds, 15 centimetres. There it is. That's the maximum. 15 centimetres at 2 seconds. The minimum, you want to make the brackets 180 degrees. So that's 5 cos 180 degrees plus 10. Cos 180 is negative 1. And that's 5. That's 5 centimetres. When does the brackets become 180? Make what's in the brackets equal 180 and solve it. At 14 seconds, the displacement's 5 centimetres. Now, it's in a context, that's all. So that's the maximum minimum. It's simply, for sine, make the angle 90 and 270, and for cosine, make the angle 0 and 360. 0 and 180. But, again, if that said 15t plus 30, we wouldn't use 0, we'd use 360, because we don't want to go into negative angles. So that's the context. In that kind of question and context, they often ask you to do a substitution into the formula for some other calculation. So it's not about, this is the maximum minimum values of the functions finished, but the kind of question you get will be also involving, that's the same function as before in the first one, and just getting to, so you can understand what you should put in for t. So it's saying depth of the water in a harbour, h metres after time, t hours after midnight is given by this expression. What's the depth at midnight? Well, that's when time is 0. And at 1 p.m, well, you think that's 13 hours into the day, t's 13. So it's just a simple substitution. Midnight, t is 0. You make t 0 in this expression. That is, there's t going in as 0. Then that is simplified. It's 10 sin 18 plus 15. You plug that into your calculator. That means the depth is 18 metres. 18.1 I've put there. So all that's happening is this is substituting into a formula. It's just reading the question, understanding that the value for t at midnight is 0, and at 1 p.m. that's 13 hours into the day, 13 hours after midnight. You make t 13, work that out. You can even plug that into the calculator, get the value, and that's the depth at 1 p.m. So that's just substituting into a formula because it comes up in these kind of questions. But that's not the maximum minimum bit. That's the other formula we got. So what's the initial displacement? That's when time is 0 at the start. What's the displacement after 7 seconds? You just get you to practice substituting into the formula. So you put t to be 0. It doesn't matter that comes out negative 30. You plug it into the calculator and out comes the answer. So the displacement is 14.3 at the start. That's when time is 0. And when it's 7 seconds, it's just you have to put 7 in place of t into the formula. You can plug that into the calculator. That's partially worked out. There's the answer. Displacement's 11.3. It's simply substituting into a formula. So that's the maximum minimum values. There's a set of notes you can download. If you click the link in the description, it'll take you to a Google Drive where there's PDFs. So that's got everything for it's just a few pages. Everything on the trig functions for the series of videos. For this video, where you did maximum minimum values, which just means looking at the function and seeing it as a sine, making the angle 90 and 270. So that 3x, it's not bracketed here, that 3x is to become 90 and become 270, and you work out the values. If you see a cosine, you make the angle 0 and 180. Even if it's complicated in the brackets, that's all you do. There's a sine, you make the brackets 90 and 270. And then you work out what x has to be for that to be the case. So there's that sheet, and you'll get answers with it. And for practice, what we last did there, substituting into a formula, because it often comes up in questions like these. This is just, there's an expression, put x to be 0, put x to be 12. You do it in the calculator and you get the answers. I've put the answers there, unrounded. The value of the function in when x is 0, you put x to be 0 in and work it out. That doesn't need a calculator, the rest of it does. So there's that worksheet, and there are a few questions on another download that's there. This has been used for trig graphs. So when you look through the questions there, there's some really hard questions at the end, but this part here, yep, from 31 through to 36 is about maximum minimum values. The answers at the back. Now, the rest of the questions in this booklet are quite tricky. They're more like the examples you've just seen, but they have trig equations in them to solve. There is a series of videos on trig equations. You would have to either know trig equations or revise it first. So from 31 to 36 is what you've just seen. So that's not many questions. But after that, come some questions in trig equations. So if you do the trig equations videos, or you already know them, you can do the rest of the booklet. That's trig equations. So after that, at 52, this is just like the examples you've seen. Depth of water in the harbour, work out maximum, minimum, but also working out depth at certain times of day. But it's also got equations in it. It tells you the height and asks you to work out the time. That requires trig equations. So at the end of very difficult, all the answers are there. So that's the last of the videos on the trig graphs. I hope you found the videos useful. Thank you.